I could get my hands on an older version on eBay. And I could learn a lot about the new hardware by looking at the old hardware. So you don't need the latest, greatest state-of-the-art thing in order to start formulating things. Silicon die analysis, I'd mentioned this a little earlier. It's a subset of the hardware teardown. Except now, instead of removing the package and looking at the circuit board, you're removing the package of the integrated circuit and looking at the integrated circuit die. Very, very useful for a lot of things. Whether you just want to image the die and get a schematic of how things work, whether you want to pull out an algorithm or a security key. There's a lot of research on this. I have a bunch of links on the next slide. Whether you want to retrieve firmware, retrieve contents from ROM, flash, all sorts of things. And it is kind of this up-and-coming area where you do need some fairly specific skills, but they're not out of reach by anybody. You know, it's just practice and learning and hands-on experience is all it is. All right, so firmware reversing, say you extract the program code from a microprocessor. You have a bunch of assembly language. Maybe that's all you need. You can start looking at assembly language, figure out exactly what's going on. Or you toss it into IDA Pro or your favorite disassembler or decompiler and figure out general program structure. What I like to do is if I pull firmware contents off a board or if I pull some data off of a memory device, I don't even care what processor it's connected to. I'll just run it through strings, look at it with a hex editor. See if I can pull out any details that might give me an idea about, is there a debug menu that I can take advantage of? Is there some administrator port? Who knows? Engineers, designers leave a lot of stuff in software, whether it's in a hardware product or whether it's running on a PC. There's a lot of stuff in there that you could take advantage of. Clues. The beauty about firmware is essentially it's just software running on a general purpose microprocessor, a little computer. Pretty much everything that's electronic based is a little computer. So you don't have to be a pure hardware guy now to use your reverse engineering skills, your software skills to figure out how the software works, maybe change the code, reprogram the device, and you're set to go. External interfaces, maybe you can't get access to the circuitry. Maybe you are looking at a parking meter that's stuck in the ground and you can't chop it off and go home with it. You can't open it up on the street. So you look at the external interfaces, things that connect to the outside world. You might monitor communications of a smart card port, of a debug port. Once you do that, you might try to decode what's going on, decode the protocol. If it's serial, it's easy. If it's something else, you might have to start analyzing things. Emulating the protocol might be useful. I'll give you an example of that. And engineers like to make their products easy to design. Manufacturers like to make their products easy to manufacture, which means easy testing and verification that the system actually works. So programming ports, debug ports. A lot of times products use industry standard connections, so if you find a JTAG port, for example, an industry standard debugging interface, you can connect to that and then control the hardware. Because engineers want to leave that stuff in, and it's a real fight to get them to remove that stuff. It's sort of the whole security versus convenience thing, and a lot of times convenience wins, and things that should be removed from products aren't. Some common themes with hardware. And these are things that just haven't changed. It's just the core of electrical engineering. And being a designer as well, I can understand where most engineers in the world are coming from. They're more concerned with getting the product to market and meeting their deadlines and meeting their budget than they are about making the product secure. As sad as that is, that's just the nature of the world. So we can take advantage of that. Most design engineers either don't care about security or they're not familiar with security. In the engineering community, the pure electrical engineering community, a lot of the security books and recommendations are, if you want to encrypt something, use XOR. And that's it. That's all it says. There's no other thought given to crypto or security or anything. So it's sort of like where the software security community was maybe 10 years ago. Right? It's like poor programming practices and buffer overflows and all these really obvious things, except the security industry got a little better, or the software industry got a little better. You see less buffer overflows and less poor coding practices. But the engineering industry, the electrical engineering industry, still hasn't changed. A lot of products are based on publicly available reference designs. Manufacturers of ICs. Chip vendors want you to use their products. They want engineers to design their chips into the product. So they make it as easy as possible and say, oh, you want to design a cell phone? Here's our cell phone chipset. Here's a reference design. Here's a basic cell phone. Now you as the customer can go and modify it and make it into your next generation cell phone. But the core reference design is from the vendor. We can take advantage of that. If we open up a cell phone and say, hey, that's using a Broadcom IC. We go, okay, that's a Broadcom chipset. We'll go to the Broadcom website and say, do they have a cell phone reference design? Yes, they do. Go to the cell phone reference design, pull down the schematics. All the information usually is available for free because the company wants you to use their tools. They're giving you as much as they can to entice you to use their stuff. So you say, okay, there's a Broadcom reference design. If you compare that to the schematic of the cell phone you're looking at, or of the design of your target cell phone, I guarantee you that there's a high percentage of similarity between the two. So that saves you a lot of time when you're actually reverse engineering. You can start using the reference design instead of starting with a blank piece of paper. Components are easy to identify, easy to access. They're still pretty big. You can look at part numbers. You can figure out what the part does. A lot of times you can just look at a circuit board, and without even knowing the part numbers, you can say, okay, there's the microprocessor, there's the memory, that must be some USB interface. The more products you look at, the more familiar you get with sizes of parts and where parts are located next to each other. And as long as that continues to be accessible to the human eye, you'll be able to figure out a high-level functionality pretty easily. There's been a ton of high-profile work going on in the hardware hacking space and the embedded security, secure hardware-related space. I just picked a few that were sort of the most high-profile and that the media really picked up on. But every day there's new stuff going on, and these links are just to get you excited about what's possible. E-voting machines, electronic voting. Rob's talk coming up next talks a lot about that, the process that he went through. Smart power meters. There's been recent research on the power meters that are connected through some wireless network, whether it's Zigbee or some other low-range RF. Now the meters are communicating with each other. There was some ATM cash dispensing bug that was pulled from Black Hat US this year. And the rumors were that there was some bug in a popular automated teller machine that would spit money out of the machine, sort of like Terminator 2. Of course, we don't know the details of that, but it's something that the media latched onto and really hyped up. But that's hardware hacking, looking at products that you just take for granted every day. And an ATM is a big one because there's money involved, right? So anytime there's money, people want to get something out of it. Tons of RFID research, whether it's passports, MyFair, HID, cloning, HITB 2. Karsten Knoll has done amazing research in this area. Chris Tarnowski. Just a lot of work. And when the media picks up on something, it doesn't really legitimize what it is, but it lets the mainstream public know about the problems. And the media has really been picking up on hardware hacking and really excited about hardware because it's a tangible thing, right? It's not a software application that somebody finds some obscure, weird bug that they can exploit through some SQL, whatever. It's a tangible piece of hardware that you can go to somebody in the media, you go to the public and say, I can spit money out of an ATM, or I can get free parking, or I can get electricity for cheaper. All of these things are easily understandable by the general public, and that's why hardware hacking is becoming more popular, because then the media writes up about it, the mainstream reads about it, and then people go, hey, that's sort of cool. I want to get into computer security. I want to start learning about things. So it's kind of generating, the media is actually helping us get more people involved to ultimately, I'd say, make the security industry better, but it just takes time. And then you have fare collection infrastructure. The Boston MBTA Charlie card was a popular one in the news because the guys from MIT that had done the work were going to give a presentation at DEF CON about breaking the crypto system of the Charlie card, which is the fare card for the Boston transit system. And Boston, being a very uptight city in the United States, called the FBI and issued a gag order and prevented these guys from actually talking about the information. A typical security or corporate response to a computer security problem, right? Every time you find a computer security problem, you're worried you're going to get sued. You're worried something bad's going to happen. You're worried you're going to get fired. These guys got sued, but what was funny is in the process of this whole lawsuit, the students had to release their information to the court. And when they did that, the information then became public. So